Hi everyone, this is Dr. Kiranmayee, professor in the Department of CSE and also taking care of the technical trainings at VNR VJEC. So today I'm going to discuss about the stack data structure. So as all of you know that the previous lecture I have given the introduction to data structure. So today we see a stack data structure. So now if you look at this particular slide, so this is a real life example of a stack. So the first example, if you see, this is nothing but stack of books where you have only one end, isn't it? So here the insertions are placed only from this particular end, right? You have only one end where all the books have been placed from this particular end. And also if you want to take out any of the book, you have to take it from the top only. And again, you take a second example where you have the pile of plates. In the pile of plates, the plates are arranged in such a way that the plates are added one by one only from this particular end called as a top. And if you want to remove any plate, you have to remove only from the particular this end only. So if you go to any function for a dinner or for a particular fun lunch, so all these plates are arranged like this. So how are you going to pick out these particular plates? We are going to pick out only from this top end. And as that is called deletion. When you want to delete anything means what? When you pick up a plate, you are going to use this one only. And once the plates are over, and you are going to insert one by one from this particular top end only. And the third example, if you see it, this is a stack of DVDs or the CDs. So you have a stand like this, right? And if you add any one of the CD, you can only add from this end called as a top, right? And suppose if you want to delete it, you cannot delete from the down because the down is already closed. You cannot remove it. So only one end is utilized for both addition and deletion. So now we have also another real life example where in day-to-day life we see in the kitchen for our breakfast, that is idli plates, right? So if you want to add any plate to this particular stand, you are going on adding like this. So what is this one now? You are adding the plates at one end. And once it is cooked, steamed, and later on if you want to remove it, can you remove the bottom plate? No, you have to remove one by one from the top only. So now we define what is a stack. So a stack is a linear data structure where both the insertion or the addition of the element or deletion of an existing element always takes place at the same end. So you have only one end. Okay? Stack has only one end and that end is called as nothing but top. Always the same end top is utilized for what? Insertion. So the insertion operation in a stack is called as a push operation. And the same top is utilized for removing an existing element from the stack. That deletion of an element or removing of an element from a stack is called as a pop operation. And generally, how to remember what is the stack means? The last inserted item will be the first one to come out. So, as we have discussed in the previous slide, the last inserted will be first one to come out. Similarly, the plate also, the last inserted plate will be the first one to come out. So generally, we say that what is the principle followed in the stack? The principle followed in the stack is LIFO. LIFO in the sense, the last in, first out means the last inserted item or the last inserted element will be the first one to come out. So now, we once again wind up with the discussion of a definition is nothing but a stack is a linear data structure which has only one end. And the same end is utilized for both the push operation and the pop operation. Now, Why we are going to use the stack? Because stack has various applications in computer science. The first one is expression evaluation. So what do you mean by an expression evaluation is, suppose you consider a postfix expression, suppose a, B plus. I want to find out what is the value of this A, B plus. So manually, you're going to say, suppose A equal to 3 and B equal to 2. Okay, so we say 3, 2 plus, it is equivalent to 3 plus 2, and you say that manually 5 is the answer. But manually, we cannot do for a longer expression. So it has to be automated. So the stack plays a very important role to find out what is the value of a expression. So that is called as an expression evaluation. Next important application is to check the parentheses matching in an expression. So in an expression, so always in an expression, the number of left parentheses must be equivalent to the number of right parentheses. Right parentheses, or else you can say the square brackets, or else you can say the flower bracket. So in an expression, the equal number of left parentheses and the right parentheses should exist to validate that is a correct expression. So for that one, stack application is it automates the process in checking whether the parentheses are matching or not. Next, the next application is it converts the one form of expression to the another. That is, here the computer can understand only the parenthesis-free expression. So always infix contains what? The parentheses. So your stack plays a very important role in converting the infix expression to postfix expression. The postfix is a parenthesis-free expression. So your stack can be used to convert an infix to postfix and infix to prefix. Okay, because the computer can understand only the parenthesis-free expression, and according to the precedence, the operators of the operands will be evaluated as the next step, that is the expression evaluation. The next is recursion. So what is recursion? So we already know that recursion is a function which calls itself. So what is the role of stack over here is, every time when you call a function itself, suppose a factorial, right? So here each time you call a factorial function, this particular function will be placed in a stack. Okay, stack frame. In a stack frame, along with the normal variables also, and the function call also will be kept. Similarly, fact of 3, then fact of 2, like that. In data structure, we see towers of Hannah is an example for recursion. And that we later see a separate video recording as a towers of Hannah problem will be solved in it. Memory management here in the normal function calls also, apart from the recursion, in the normal function calls also, each function call, we are going to use a stack frames. Okay, so here the parameters will be in each stack frame, the parameter, the local variables, and the function call will be kept over here. And the last, the function call will be again the popped off to evaluate the particular function. Backtracking problems in many situations, right? If at all a path, you could not find a path to go forward. In that case, we can move back to the previous path and then solve a solution to it. So suppose an example is, I want to find out in breadth first search, I want to find out. Okay, so in the case of the depth first search, I want to find out the on a graph, isn't it? So here backtracking exists over here. That is, whenever you cannot move forward, so you can use a stack, so that because all the nodes in the graph of a depth first search are kept in the stack. So if there is no path moving forward, what we do? We go back to the previous path and then you're going to visit the next particular node. So these are all the applications of stack, that why it is very important in computer science. Now this stack, now we have to implement it in any of the languages, either C, Java, whatever you wanted. If at all we want to implement and execute this particular stack, you can implement using the concept called as arrays. Or also you can use the second, the concept is linked list. So a stack can be implemented using a linked list, it can be implemented in an array. If you are going to implement with an array, you are going to use a static memory allocation technique. And if you are going to use the linked list, you are going to use dynamic memory allocation for creating the stack. Okay, so now today we are going to implement the stack using arrays first. Okay, so first you have to create an array. Okay, here you are going to assume array as nothing but a stack. Okay, so here if you want to implement it, we are not going to now discuss about the C program to implement a stack over here. We see what are the various operations performed on a stack, and we write some algorithms on those operations such that it will be easy for you to write the code on your own. So now initially, what are the various operations to be performed on a stack if you want to implement using an array? So the first operation is the push operation. So we write the algorithm for push. Then the second operation is what? The pop operation. And the third one is what? Now at any point of time, I need to find out what is the content of the stack. That is, I want to display what is the content of the stack. Right? So first we see what is the push operation. Then we write the algorithm for push. Then we see what is a pop operation and then write the algorithm for it. Then comes to the display, how the elements of the stack will be printed. So now, this is an example where a push operation is performed on a stack. So we are going to consider this is an array. Okay, this is an array. So I told you what is the stack here. Stack is a linear data structure which has only one end called as a top, and always initialize the top to -1. That is, initial value of top is -1. Now, if you want to insert an element, that is the push operation you want to perform it, same top will be utilized. And if you want to pop, that is delete an element from a particular stack, then use the same particular end called as a top. Now, consider this initially your top equal to -1. Whenever top is -1 means what? Your stack is empty, means it does not contain any element. So, whenever you are inserting an element or is performing a push operation, we need to check for whether it is, check for the overflow condition. So, what do you mean by overflow mean? Suppose, take a bucket of water, right? Your bucket of water is already filled, right? Now, can you still add water to it? No. So this is what? An overflow condition. So whenever you want to perform a push operation, the first condition you have to check it is what? Overflow. Means already if your stack is full, you cannot insert element into that particular stack. So now here initially your top is -1. Means your stack is empty. So you can insert. So when you want to insert an element into a particular stack, you have to increment your top first. Okay, increment your top means top is equal to top plus 1. So your top now becomes 0. Now the 10 will be inserted. Okay, I am inserting an element at the top. Now top is -1 initially. Now top becomes what? 1. Sorry, 0, because you have incremented. Now still I want to push another element. Suppose push 20. Again what? Increment it. Increment the top. Now the top is 1. 20 will be pushed. Still I want to push 12. Your increment the top, place an element. Increment the top, place an element. So 33 is added. Now your stack size is only 4 now. Okay. So in real, the stack size must be 100, 200, but for as an example, we are discussing with a very small size stack. Now, the size of the stack is 4 now. So since you're starting from 0, okay, so now your particular stack is full. So whenever your top reaches over here, right, max minus 1. What is the size of your stack? Nothing but max. Since you're starting from 0, you have to check for what is the overflow condition. I told you check for the overflow condition whenever you want to perform the push operation. So whenever it reaches the max minus 1 or greater than max minus 1, you should say overflow. You cannot insert an element into a stack. Otherwise, increment the top, place an element. So this is an example for performing the push operation. Next we see the algorithm now. What we have just discussed. Now push of x. So suppose your x value first is, I have pushed 10, isn't it? So push 10 you're saying. So I am checking whether it is max minus 1. So what is this one? I am checking overflow condition. So whenever you want to insert an element or perform a push operation, you check whether there is a space in the stack, right? So if top equal to minus 1 means already your stack is full. Okay, so suppose 10, 20, 30, 40, already your stack is full. Your top is over here. So what you have to display? So you say your stack is full. You cannot perform a push operation or insert an element into a stack. Else what you have to do it means you have some space over here. Suppose your top is over here. So what you have to do now? You have to increment the top and place an element over there. So incrementing a top. What is x now? What is the value you have inserted? Want to insert that x, where you are going to place it? Stack is the name of the array because you're assuming the array as a stack because you're implementing stack using an array. So stack of top. So stack of top means what? You're inserting next is 20. Right? So x will be inserted at where? Because push operation or the pop operation, only one end is utilized for the insertion or deletion. So you're placing it. End of that particular push. So this is the algorithm for the push operation. Always check for the overflow condition. If there is an overflow, say that you cannot insert an element or perform the push operation. Otherwise, you increment the top and place an element. That's it. That is about the push operation. Next. So push is finished. Next is a pop operation. So what is a pop operation here is, I want to delete an element from the stack, right? So before deleting an element, you check whether your stack is empty. Because see, suppose again same the example, take an example of a bucket which does not contain any water. Can I remove water from it? Okay, no. Means what? You're asking an empty bucket to remove the water from here. It cannot happen. That is nothing but underflow. Similarly, if your stack is empty, means does not contain any elements, then it's not possible to remove an element. So always make a habit of checking for an underflow condition whenever you want to perform a pop operation. So here see, your stack contains some elements. Here what you're going to do, first perform a deletion. Okay, perform what? If at all there is elements in the stack, first perform a pop, means what? Delete it. And then what you're going to do? Decrement it. Top equal to top minus 1. So 33 will be deleted. So first delete and then decrement the top. Again I want to perform the pop operation. Here I want to say always the element on the top only will be removed. You cannot say remove 10, remove 20 or push 10, pop 10, pop 20. You cannot do it because always the element on the top only to be removed. Right? So I want to, next on the top you have 12. Okay? Perform the pop operation. So 12 will be removed, your top will be decremented. Then again perform the pop. 20 will be removed, decrement the top. Then 10 will be removed, decrement the top. So whenever your top reaches to minus 1, your stack will be empty. So whenever your stack is empty, it is underflow. So you say that whenever a stack is empty, you say it is a underflow condition as met. So you cannot pop an element from a stack. So this is about an example. Next we see an algorithm. So see, pop operation. So first what you're going to check, this is what? An underflow condition. Underflow, you're checking whether the stack is empty. If a stack is empty, you cannot remove an element or perform a pop operation. Otherwise, what you're doing else? What you're doing? Always element which is present on the top only, okay, will store in some temporary item, that is a variable, and then decrement it. You are removing, you are decrementing. That's all. If you want to know what is the particular element to be removed, that particular element will be returned to the main function, right? So take care that whenever you're performing a pop operation, check for the underflow. If at all elements are already there, you can just remove it and then decrement the top. So we are completed with the push and pop operation. Now I want to display what are all the elements that are present in the stack. I want to display on the screen. So now 10, suppose 20, 30, 40. Some space is there, but your top will be over here, right? So because it is an array, using stack using arrays, your indexing starts from 0, right? So here display also, you check whether the stack has some elements, okay. If at all the stack is empty, means nothing will be displayed because your stack is just empty. No elements will be displayed. Otherwise, else means for I is ranging from. So I is what here? I is initially 0. I is ranging from, top to 0. Why? Because you cannot say 0 to top, right? 0 to top you cannot say because the stack is always here from the top to the bottom, that is 0. That is the case whenever you are displaying the content of the stack, display from top to 0, right? So what you're going to do, always from ranging from top to 0, print first 40 will be printed. After that 30 will be printed, then 20, then 10. So here I will be decremented here. So 40, 30, 20, 10 will be displayed like this, 40, 30, 20 and 10. This is the content of the stack. So these are the main 3 operations performed on a stack: push, pop, display. If at all, you can also perform an operation like is empty. Is empty is nothing but already you have checked. You can write a separate function for underflow. Writing a separate function for underflow is empty. And similarly, is full function also you can write it separately. This is nothing but checking for an overflow condition, right? You can also say operation called as peak. So what is the peak will do is always display the element which is present on the top. That is about the peak. And suppose size also you can do it, perform the size. What is the size? Here at any point of time, if I want to know what is the size of the stack, that can be done by the stack. So in detail, if you want to write a stack program using arrays, the main or push, pop and display. If you want to still go ahead with writing is empty, is full, peak and size, this is about is empty means underflow, is full means overflow, peak means the top element of the stack, size means what is the size of the stack. This is about the stack. Now we discuss about what is an abstract data type. So every data structure, we say it is an ADT. So what is an ADT here is, I will give about a real life example over here. So what is the just a real life example of an abstract data type is, the best example is ATM machine. So if you approach an ATM machine, generally what the user is bothered about, the user is bothered about first what? To check the balance of the balance amount, okay, or else he can withdraw, isn't it? He can withdraw the money or else he can deposit, right? So, whenever the user approaches the ATM machine, he is interested in checking the balance, withdrawing the money, and depositing money. And the user does not bother how the money is kept inside the machine or else how the server is running over there and how the machine is going to count the money. That is not bothered about for the user. So here only the front end part we are interested in. We are interested in only these three particular things: checking, withdrawing, and depositing. Similarly, here also, abstract data type means you are going to define the data and also what are the various operations that can be performed on the data structure. But we are not interested in the implementation details, right? So, abstract data types are the entities that are definitions of data and also operations performed on the data. But how it is implemented, what is used, that is not, you're hiding over there. So that is called as an abstract data type. Now, how to write an abstract data type for a particular stack? So this is an abstract data type for a stack. So here, the coding part and how it is implemented, what are the several, all these coding we are hiding over there. We are interested in only what is the data and what are the various operations you can perform it. So here we are telling that your stack is a data structure. So first operation is full. So this is used to check what? This is check for what? Overflow. Just I have discussed, right? You say that is full mean this is used to check whether stack is full or check for the overflow condition. Similarly, is empty mean here you're going to check for an underflow condition or say whether the stack is empty. Push. This is an operation, just now we have discussed that, to add an element to a stack. Then pop, that is removing element from a stack. Then peek, this is always to access the top element of the stack. And then size, you are going to say the number of, how many number of elements currently present in the stack. This gives about the size of the stack. So this is the actual template for that stack we have discussed. So similarly, you can write it for the other data structures like linear queue, okay, circular queue, then linked list. So for various other data structures also, this is the way how to write an abstract data type. So I conclude saying that this is the video recording on the stack and the abstract data type for the stack. And in the coming videos, we discuss about the linear queue, circular queue, double-ended queue. Thank you all.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.